Okay, let's take a look at objective 4, and here we'll be solving rational equations. And what we want to first do is we want to multiply both sides of the equation by the LCD. So as you can see here, our LCD is x times x plus 1. So we have to multiply both sides of this equation by that. So we have x plus 1, and we're going to multiply by x times x plus 1. And then we're going to add 1 over x and multiply by x times x plus 1. And then we have that's equal to 5. And we're multiplying by x times x plus 1. So as you can see, we have in this case, we have the x plus 1's cancel. Here we have the x's cancel. So now, as you can see, we have 5x squared plus x plus 1, so plus x plus 1, equals 5x times x plus 1. So we have quite a bit of work to do because we need to have that right-hand side set equal to 0 if we have a squared term remaining. If we don't, we will just solve the way we solved in the first objective. So let's do first things first. Go ahead and write this left-hand side down and distribute that 5x squared. And what do you know? We can subtract 5x squared from both sides. Let's just go ahead and subtract x from both sides. And we end up with 1 is equal to 4x. And now we can see that x is equal to 1/4, dividing both sides by 4. Maybe I'll go ahead and show that, move that over here. Dividing both sides by 4. And then, of course, we have x equals 1/4. Okay. Well, that just doesn't want to grab it. Let me just see if I can move this down. And bring that up just a bit. Okay, let's do the same thing on number 9. What do you notice? Our LCD is going to be z squared. So we will take every term and multiply it by z squared. And as you can see, here, one of our z's cancel, and here, both of our z squareds cancel. So we have 7z squared plus 20z is equal to 3. Now, we do have, in this case, we do have a squared term and a z term. So we will have to subtract 3 from both sides. So we set that right-hand side equal to 0. Okay, so now we can go ahead and make our little cross here, and we will have two numbers that multiply together to equal a negative 21, and when you add them together, they will be a positive 20. So, of course, we have a positive 21 and a negative 1. So now we will divide both of these by 7z. And here we have 7z minus 1, but we will reduce this to 3. 21 divided by 7 is a 3. So now we can go over here and write that this is equal to z plus 3 multiplied by 7z minus 1. So either z plus 3 equals 0 or 7z minus 1 equals 0. So z is equal to negative 3 or z is equal to 1/7. Okay. Okay, let's go ahead and look at number 10. We also might want to mention in these two problems, I'll go ahead and do this in green. Here we notice that our restrictions is x cannot equal a negative 1 and x cannot equal 0. And as you noticed, we are okay with our solution. Taking a look here, we notice that z cannot equal 0, and we didn't get 0 for either of our solutions, so we were okay. Let's go ahead and write the restrictions here after we factor. So this is m times m minus 3, and of course we have m minus 3. So as you can see, m cannot equal 0 and m cannot equal 3. These are our restricted values. And we'll write that we need to check those restricted values. Okay? Okay. So let's go ahead and write our LCD here. Our LCD is m times m minus 3. So we are going to go ahead and multiply both sides by that. So we have 18 over m times m minus 3. And we're multiplying that by m times m minus 3. And then we have plus 2. And we're multiplying that by m times m minus 3. And then we have equals 6 over m minus 3. And we're multiplying by m times m minus 3. So here, both of those factors cancel, and here the m minus 3's cancel. So we end up with 18 plus 2 times m minus 3 is equal to 6m. So we have 18 plus 2m squared minus 6m equals 6m. So this worked out nice because we can go ahead and subtract 6m from both sides. And now we have, and I will be working at the bottom of the page in a moment. Let me write what this is going to be. This is going to be 2m squared minus 12m plus 18 equals 0. So let me move that over just a little bit so I can write equals 0. And then we are going to divide every term by 2. And this is what we will be solving. M squared minus 6m plus 4 equals 0. And as you can see, what we have here is that we have two numbers. So I believe this is an 18. I think I made a little error here. this was an 18, and then this would be a 9. So here we have m minus 3 times m minus 3 equals 0. So m minus 3 equals 0 and m equals 3. However, we cannot choose m equals 3 since that's a restricted value. So therefore, there is no solution. And we could actually write empty set. Okay, not a lot of room for number 11, so I will put an extra page at end. And rewrite that problem, okay? So I will go ahead and do that now. And we will write that problem. So that would be 30k to the negative 2. So this is number 11. And then we have minus 23k to the negative 1. And then we have plus 2 equals 0. Okay, let's take care of those negative exponents and go ahead and do what we need to do, which would be, this is 30 over k squared minus 23 over k plus 2 equals 0. My LCD is k squared. So we have 30 over k squared times k squared minus 23 over k times k squared plus 2 times k squared equals 0. So as you can see, our k squareds cancel here. Just one of our k's cancel here. So we have 30 minus 23k plus 2k squared is equal to 0. Let's rearrange our terms so that we have them in descending powers. Okay, so now what we have is two numbers multiplied together to equal a positive 60, but add up to a negative 23. And as you can see, we have a 20 and a 3, and they both need to be negative to add to negative 23. So now we'll divide both of those by 2k. And this is finished, but this is a negative 10 over k. And I can actually move this over to the right a little bit and make it a little bigger. And now we have k minus 10. So this is equal to k minus 10 multiplied by 2k minus 3. So either k minus 10 is 0 or 2k minus 3 is 0. K is equal to 10, or K is equal to 3/2. Okay, let's go ahead and look at our original equation, and let's take a peek at what our restricted values are. We are restricted. K cannot equal 0. We did not get 0. We are okay. So both of those answers k equal to 10, and k equal to 3/2 are our solutions. Okay, moving on to number 12. We have that we can subtract 4 from both sides. So we want to isolate the radical first. So now we have the square root of x is equal to 2. And so now we will square both sides, and we come up with x is equal to 4. Now we will need to check our solutions. And we do that when we square both sides. We must check all solutions. So if we go ahead and check, in the original equation, the square root of 4 plus 4 is equal to 2 plus 4, which is equal to 6. So we are checked. Let's take a look at number 13. We can go ahead and square both sides since our radical is already isolated, and we have 5y plus 1 is equal to 16. We will subtract 1 from both sides and have 5y is equal to 15. And dividing both sides by 5, we end up with y is equal to 3. Going ahead and checking that, we have the square root of 5 times 3 plus 1 is the square root of 15 plus 1. That is the square root of 16, which is equal to 4. And that was our original problem. So y equal to 3 is a solution. Okay, looking at number 14, we are isolated, so we will square both sides, and note that we will be squaring x plus 1. So here we have x squared plus 5 is equal to, let's keep in mind that this is x plus 1 times x plus 1. So we have x squared plus x plus another x, so outer and inner is 2x plus 1. We will subtract x squared from both sides, and we end up with 5 is equal to 2x plus 1. Subtracting 1 from both sides, we have 4 is equal to 2x. We will divide both sides by 2, and we end up with x is equal to 2. Let's go ahead and check that solution. So we have the square root of 2 squared plus 5, and we want to see if that's equal to 2 plus 1. So that is the square root of 4 plus 5. Is that equal to 3? Check. So we are good to go with our solution x equal to 2. Okay, looking at number 15, we are not isolated, so we will need to subtract 3 from both sides. And we have the square root of 2n plus 29 is equal to n minus 3. Since we are isolated, we will square both sides. And here, keep in mind, we have n minus 3 multiplied by n minus 3. So we have n squared minus 6n plus 9. So we do have a squared term, so we will have to bring everything over to one side. Let's subtract 2n and 29 from both sides. So we end up with a 0 equals n squared minus 8n minus 20. So, as you can see, we need two numbers that multiply together to equal a negative 20 and add up to equal a negative 8. So here we have a negative 10 and a positive 2, dividing both of those by n, and we have n minus 10 multiplied by n plus 2. So either n minus 10 is 0 or n plus 2 equals 0. So we get n equal 10 and n equals a negative 2. Now we will need to check those. I'm going to move this over here. And I will put that like that. So we do need to check our answers. Let's first check n equal to 10, and then we'll check n equal to negative 2. So we have the square root of 2 times 10 plus 29 plus 3, and that is equal to the square root of 49 plus 3. 7 plus 3 is equal to 10, what we started with. Okay, we will now check n. So n equal to 10 checks. N equal to negative 2, we have the square root of 2 times negative 2. See if I can move everything over a little bit. Probably should just leave it alone. Okay. And we'll put that about like that. And then that would be plus 29, and then we need to add a 3. So that's the square root of negative 4 plus 29 plus 3. So that's the square root of 25 plus 3. 5 plus 3 is 8. That is not equal to negative 2. So that does not check. So we only have one solution, and that's n equal to 10. And that concludes this worksheet.